Right, let's start with some true and false questions. Let's look at A. Is that true or is that false? What do you think?
It's false.
Okay, why? Why is it false? Because you have to show your steps, right? If it asks you to explain it, what does the left-hand side of the equation give us? What's 9 to the power of 1 over 2?
It's 3,
Yeah, what's 4 to the power of 1 over 2?
2.
2, right? This should be equals to 25 to the power of 1 over 2, yeah? 5 is the square root of 25. That's what it should be. What is it here? It's 13. 9 plus 4 is a 13 to the power of 1 over 2. And these two numbers are not the same. That means this statement is false. What about D? True or false? Okay, if you don't know, let's just do this. Well, how would you simplify this? We have 1 over A times 1 over B. What does that simplify to?
1 over AB.
Okay, 1 over AB.
And
Let's,
then can't you flip the fraction
yeah, you
to
can
get a
flip the
positive?
fraction. So this becomes upside down, that becomes 1. What's AB over 1 to the power of 1?
It's just AB.
It's AB. So is this true or false?
It's true.
It's true. What about B? True or false? What's 36 to the power of 1 over 2?
It's 6.
It's 6, right? So this side simplifies to 6. The other side, left side, simplifies to 5. Is that true or false?
False.
False, right? So this is false. E. What do you think? Is this true or false? What about if it was just something like something like this? Is this true or false?
It's true.
It is not true. Let me show you why. It's a very common mistake. If you have x plus y squared, that means it's x plus y to the power of x plus y. Let's open this bracket. X times x is x squared. X times y is xy. Y times x is yx. Y times y is y squared. You're good. X squared plus 2xy plus y squared. Okay?
Mm-hmm.
If there's a power here, the number of terms, this is called n. This is also called a degree. The number of terms that you get after opening the bracket, okay? It's always going to be n minus 1, or sorry, n plus 1, the number of terms. So if you have squared, that means you're going to get 3 terms. let's say if you have x plus y to the power of 3, whatever that is, if you open the bracket, you'll get 4 different terms, okay?
Mm-hmm.
Here's a power 6 here. If you open this bracket, how many terms are we expecting?
7.
Exactly, you're expecting 7 terms. On the right side here, we only have 2 terms. So is that true or false?
False.
False, that's right. What about this one? Same kind of
It's
idea.
true.
It's true. Let's see. What's the LCD between A and B? It's the lowest common denominator. That's what LCD is. If you don't know, just multiply them. That would always be right.
So it's AB.
The LCD is AB, okay? So you need to multiply this by B, top and bottom. So that becomes B over AB. What does the second term become here? You need to multiply this by A, right? For it to be an AB on the bottom. So you'll get A over BA, or it's the same thing as AB. Let's combine that. That's B plus A over AB to the power negative 1. What does that equals to?
AB over B plus A.
Yeah. So is that true or false? Because that's what it's simplified to. Is this the same thing as this?
No.
No, it's not. So you see, sometimes things are a little bit trickier. You have to, the power matters, and yeah. So this is not true. That's another common mistake. It's because if you open this bracket, I'll show you why it's not true. You'll get something like this, okay? That
Mm-hmm.
this thing is tricky when you distribute it inside, when there's a plus sign. If there's a time sign, yeah, sure, that you can distribute it. It's gonna become A times B if there's a time sign. But if there's a plus and a minus sign, distributing that power is tricky. Okay, you can't do it, you can't just throw it in. It's usually unconventional. So that is false. Plus and minus is a little bit trickier, but this one is a times. This one is a one-step answer. Is that true or false?
It's true.
Yeah, it's true. This one you can throw it in. Why can you throw it in? It's because there's a times. Times you can throw it in. Plus and minus, no, you cannot. This one is true. Okay, now we have an equation with radicals, radical equation. Same kind of idea. Just remember your exponent laws. It's not that tricky. The 1/4 there, right?
Mm-hmm.
What does that mean? What
The
can we do with that?
1/4.
That's the 4th root of 1 over 16, yeah?
Mm-hmm.
Minus the 3rd root of 8 over 27. What's the 4th root of 1 over 16?
It's just 1/2.
Yeah. What's the 3rd root of 8 over 27?
Two over 3.
2 over 3. So we have 1 over 2 minus 2 over 3 is equals to square root of x squared. How do you simplify 1 over 2 minus 2 over 3?
You find the common denominator.
Right, so that's 6, so you multiply this by 3. Okay, this, we're not gonna do much of this, but yeah, you find the LCD, you get 6, you get 3 minus 4 is negative 1 equals square root of x squared. All right, what's the square root of x squared?
X.
X. So this cancels out of this, therefore the final answer is negative 1 over 6 equals x, and we're done. So not that complicated. Even this one is very simple. What's the third root of 1 over 8?
It's 1 over 2.
It's 1 over 2. Fourth root of x4.
X.
X. 15. Fourth root of 16.
2.
2. So I'm going to throw this aside. X is equals to 15 minus 2, 13 plus 1 over 2. So x is going to be 13 and 1 over 2, or 27 over 2. And that's the answer, okay? It's pretty simple. It's nothing too complicated, that one. So here, what can we do? What would be the first step?
Distribute.
All right, let's distribute. What do we get?
8x to the power of negative 9 and y to the power of 6.
Right, and on the bottom you get y6, y negative 8. Right, so 8 is there. That's the only number, so we can't do much with it. What's x negative 9 over x6? What does that simplify to?
Negative 15.
Right, so x negative 15. What about y's?
14.
14. So the thing with exponents is that you cannot have, well, you can have, but usually for the final answer, you would make all the exponents positive. We do not want a negative exponent in the final answer. So how do we make these two exponents positive? Right now they're negative.
The 14 shouldn't be negative.
Yeah, what's that? That's 17. The 14 is positive. How do we make this positive?
You throw it in the denominator.
Right. Does the 8 stay on top, or does it also go to the bottom?
It stays on top.
So the final answer will be something like this. And you are done. So you just distribute the thingamajig. What about this one? Let's first clean this up and then we'll throw the numbers in there. What would be the first step? How do you clean up the x's?
You multiply.
Okay, so what do we get? So we're multiplying. The x's are being multiplied, right? When
Mhm.
you're multiplying, you add up the exponents. So here you just add the exponents. What's 2n plus 1 plus 3n minus 1? We're going to add this with this. And that'll be the exponent for the numerator there.
It's 5n.
5n, right? And then we have over x to the 2n minus 5. Now what? Now they're being divided.
You subtract the exponents.
Okay, so what will that give you if you subtract them? Be careful here. Take away 2n minus 5 from 5n.
3n minus 5.
Try again. Close. And 5n minus 2n minus 5. It's a double negative, okay? It should be
CI.
3n, yeah, 3n plus 5. So be careful there. Whenever you're subtracting something, just put this latter term, the second term, in a bracket, because it could be double negative. If this was a plus here, then that would be a minus. If that's a minus, then that would be a plus. So just careful there, subtracting that. And here, we're gonna finally plug the numbers in. So x is -3, n is 2. So you get -3 to the 9 plus 4, which is 14, whatever that is. And that'll be the answer to the question. Cool?
Mhm.
14, or what did I get? How's that 14? That should be 11. 6 plus 5, yeah. Same idea, and that's going to be a big number. We don't have to do that. Is that going to be positive or negative? The answer to this question. -3 to the power of 11. Positive number or negative number?
Negative.
Yeah. What about rational exponents? Here. What do we get on the numerator? Same kind of idea.
You cube root it.
Okay, so it was a cube root. What do you get on the numerator? It's a cube root of 27. So what you do is you just cube root everything in the numerator. Cube root of 27 is a 3. What's the cube root of a to the -3?
Is it a to the -1?
It is. What's the cube root of b12? So cube root of b to the power of 12. Remember this, the index always goes in the denominator. So if you want to rewrite this in exponential form, you
It's
get,
b to the power of 4.
right, so you'll get something like this. What about on the bottom?
You square root everything.
Right, so 16 is 4, square root of a, -8.
To the power of -4.
Yeah, -4. You just straight up divide them, right? And 12 over 2 is 6, like that. Now 3 over 4 stays where it is, okay? Now I'm deciding what to do. I could bring this up there. So it becomes what? If I bring the -4 up there, it becomes
Positive.
+4. So you get -1 plus 4, you'll get a3. What about the b's? Should I bring the 6 up or the 4 down? if I want a positive exponent. If I bring the 6 up, I'll get b minus 2, yeah?
Mm-hmm.
If I bring the 4 down, I get b2. So I would rather bring the b down because that'll give me a positive exponent to begin with. You can always take the 6 up, but that'll give you a negative exponent, so that's an extra step of bringing it down. But if you see it, it's going to give you a positive exponent to begin with. Save yourself a step like this, okay? Do you understand why we brought the 4 down instead of bringing 6 up?
Uh-huh.
It's because we wanted a positive exponent, that's why. If you get something complicated like this, what you should do is work your way from the inside to the outside. Do not touch this bracket. Leave the outer bracket till the end. So from the inside, you kind of work your way outside like this, okay? So let's look on the inside. I'm not going to touch this outside bit. The only way to do this would be to put this in exponential form and then clean it up. So we have the 5th root of x power 8. If I want to rewrite that in exponential form, what do I get?
X to the power of 8 over 5.
Right,
And x to the power of 3 over 2.
right, 3 over 2. Now, do we add them or subtract them?
Subtract.
Subtract. What's the common denominator between 5 and 2?
10.
10. So we need to multiply this guy by 2. We need to multiply this guy by 5, right? Like that.
Mm-hmm.
So you get x to the 16 over 10 minus 15 over 10 cubed, yeah?
Uh-huh.
So that's x to the 1 over 10 cubed. What does that give us?
X to the power of 3 over 10.
Right, x to the power of 3 over 10. That denominator there is your index. So if you want to rewrite this in exponential, sorry, in radical form, what do we get? We have x to the power of 3 over 10. We want to rewrite this in radical form.
The 3rd root of x to the power of 10.
Right, 3rd root of x to the power of 10. And that's it for that. We flipped it. Did I flip it? 3 over 10. It's the other way around, right? It's the other way around. The denominator is your index. Yeah.
Oh, mm-hmm.
The denominator is your index. That's going to be 10th root of x cubed. Let's look for interesting questions here. Okay, this one. It says in party, so they've given us an expression. We have x and y. The first question is asking us to plug these numbers in and then evaluate it. Okay, let's do that. Let's plug those numbers in. So we have negative 2 to the power 7 times 3 squared to the cube over negative 2 to the power of 5, and then we have 3 to the power of 4. Yeah, like that.
Mm-hmm.
I'm just going to plug this in because I think that's what they want us to do. So negative 2 to the power 7 times 3 squared to the power of 3. So you get 4608 on the top. On the bottom, negative 2 to the power of 5 times 3 to the power of 4. You get negative 2592. Is that exactly 2? No, it's not. It's negative 16 over 9. So that's what I got after we plugged it in straight up, right? No simplification required. Now let's do it the way part B wants us to do it. Part B wants us to first simplify it and only then to clean it up. So let's simplify this. What do we get? We're trying to clean this up. Let's look at the numerator. X7, there's nothing going on, so we're going to leave that as is. What about y2 cubed? What does that simplify to?
Y to the power of 6.
That's right. On the bottom, we have x5, x4, y4, sorry. So 5 is going to go up top. We get x squared, y squared. Do you agree with this?
Mm-hmm.
We didn't get the same answer though. 6/4. So that's -2 squared times 3 squared. 4 times 9, the answer should have been 36. What did I do here? Let me replug this on the calculator. -2 to the power of 7 times 3 to the power of 6. Okay, so that was not right. So this was supposed to be negative 93,312 divided by 2592. Yeah, you get 36, not 16/9. Which one seems more efficient, do you think? Simplifying it first or just straight up plugging the numbers in? Which one would you do?
Simplify it.
I think so. I think simplifying is better. That's the way I prefer it. Because otherwise you'd have to use a calculator and things get difficult pretty quickly. So it says simplify the answer with positive exponents, all right? Here, if you open the first bracket, what do you get?
PQ to the power of -2.
PQ to the power of -2, like that?
Mm-hmm.
No, try again. Half right.
Oh, P to the power of -1.
Yeah, P to the power of -1, and then we have P3, Q3. This is being multiplied. If they're being multiplied, you add the exponents. So -1 plus 3 is 2. Q's are also being multiplied, you add the exponents. So you get P2Q, and that'll be the final answer. Let's look at E. If you open the brackets, what do you get?
W to the power of 4 and then X squared.
What about on the bottom?
X to the power of -2.
And then W3. Do you bring the x -2 up, or do you bring the x +2 down? You can either take this up or bring this down so that we have x's on the same side. Which one's better?
You bring it up.
Yeah. If you bring it up, it's going to be x4. What about the w's? What does that simplify to?
Just W.
Just w, and we're done. Let's look at F. This one looks a little bit complicated. No worries. Just start from the inside, work your way outside. So we're not even gonna touch this -2. Let's look at the numerator here. We have a -1 exponent, right? What does that say? If you open the brackets, what do you get?
A to the power of -1 and then B to the power of -1.
Right. And on the bottom, we have a squared and b -3. Okay, now you decide which one to take where and what does that give? What do we get on the top? What do we do with the a -1? Do we leave that, bring the other guy up, or do we take the a -1 down?
You bring it down.
Okay, what do you get if you bring the a negative down? A to the power of what?
3.
3. B -1, B -3. Which one? Well, you're gonna bring this up, yeah? What does that give if you bring that up?
B squared.
B squared. Now let's finally open this bracket. Actually, you can use the rule because you have a negative exponent outside. What is
Yeah,
that?
flip.
Yeah, you flip it. So A3 over B2 to the positive exponent. What's the final answer?
A to the power of 6 and then B to the power of 6.
Right, and you're done with that. Wasn't too difficult. We're getting there though. Let's look at this guy. So here, if they have brackets, just open the brackets up. If you open the R bracket, what do you get?
R to the power of 6.
Right, what about on the bottom?
P to the power of 4 and then R squared. And then P to the power of -2.
All right, so now let's clean the P's and the R's on the bottom. P4 and P -2, what does that give on the bottom? P4 times P -2.
P squared.
P squared, right? Now the R2, do we keep it there or do we take it up?
You can move it up.
Yeah, you move it up, you'll get an R4 on the top. And finally, this P -5, you have to move it down. P7, right? And that's it. That's the final answer. It's just a 3-step thing. Well, this one looks a little bit annoying, but again, it's the same idea. Clean it up and then it's gonna work out nicely. Do not touch the thing on the outside until you've cleaned up the inside. So you'll get x -3, y -1, x4, y3, x4, y +6. On the top, how many x's and how many y's? So you have x -3 and x4. They're being multiplied, so we add up the exponents, we'll get x1. What about y -1 and y3?
Y2.
Y2. Bottom stays unchanged. So we have to bring both the x and the y's down, yeah? See that?
Mm-hmm.
To make them positive, so you get 1 on the top, there's nothing left on the top. 4 minus 1 is 3. 6 minus 2 is 4. And there's a -1 on the outside. What's the final answer?
You just flip the fraction.
Yeah, just flip the fraction. So x3, y4, and you're done. Over 1 to the power of 1 is redundant. All right, what do we do here? What will be the first step?
You disroot the exponents, like from the inside.
Yeah. So you get 32 to the power -2 and x to the power -10. On the bottom, you get x to the power -10. Does this and this cancel out? We have x -10 on the top and the same thing on the bottom. Do they cancel out?
They do.
They do, yeah. So we have 32 to the power -2 to the power 0.2. Now what? What is 0.2 as a fraction?
1/5.
1/5. Now, if you throw that 1/5 inside, what do you get?
Doesn't it just turn into like the 5th root?
Yeah, it does. So you have the 5th root of 1 is a 1, so 1 is redundant. So you get the 5th root of 32, okay, squared. Or you get the 5th root of 32 squared. This one, the order doesn't matter. You can do whichever one you want to do first. I'm gonna try and do this without using a calculator. That's why I'm gonna do this first, okay? What's the 5th root of 32?
2.
2. So the final answer is 1/4 or 1/2 squared, and you're done, okay?
Mm-hmm.
It's not that bad. Same idea here, and I'll tell you the answer. The 10th root of 1024 is 2. The 9th root of 512 is also 2. So the numbers are 2 and 2's. What's the 10th root of x20? 10th root of x20.
It's x squared.
It's x squared. The 9th root of x27.
X cubed.
X cubed. Do the 2's cancel out?
They do.
They do. x2 over x3, what's the final answer?
1/x.
1/x, yeah, and you're done. Here you could plug the numbers in, or you're gonna get huge numbers if you plug the numbers in. I don't like them. We're gonna clean it up first. Let's look at C. That 1/2 applies to every element inside, okay? To the power of 1/2 is the same thing as the square root. So if you open the bracket in the numerator, what do you get?
9x squared, and then y to the power of 3.
Right, so what about on the bottom? The 8 stays where it is. What's the cube root of x9?
It's x to the power of 3.
Right, and y becomes a 1. So what's the final answer here? Or does it simplify to? So the numbers stay wherever they are. The x2, do we leave it up or do we throw it in the bottom?
You throw it in the bottom.
Right, you'll get x1. What about the y's? What do you get on top?
Y squared.
Y squared. And then finally, you want to plug in what they want you to plug in. So y is supposed to be 5, so 9 times 5 squared over 8 times 10, yeah?
Mm-hmm.
Can we do anything with this? 9 times 25 over 8 times 10. What do we do with this? So 5 goes into 25 5 times. 5 goes into 10 twice. So you have 45 over 16 as your final answer, and you're done. Cool.
Mm-hmm.
Right, so same idea for D as well. So again, work your way from the inside to the outside. So the outside, the square root 1/2 means the square is going to stay there for now. If you FOIL this, you get 25 to the -1, a to the -4. On the bottom, you get 7 squared, a -4, b squared. All right, now what? Do the a4s cancel out?
They do.
They do. So this is gone, this is gone. 25 to the -1, what do we do with that? Do we just leave
Do
it
you
there?
move it to the denominator?
Yeah, we move it to the denominator. So you'll get, what do you get on the top if you move that to the denominator?
A 1.
A 1. So you get 1/25 times 7 squared times b squared, 1/2, yeah?
Mm-hmm.
Square root of 25 is 5. Square root of 7 squared is a 7. What's the square root of b squared?
B.
B. So you have 1/35b as your answer. There's no a's. That means b is 10, so the answer is 1/350. And that'll be the final answer, and you are done. Okay?
Mm-hmm.
These are all the same kind of ideas. It's not too bad. Alrighty, what do we do here?
You distribute the -3.
Okay, what do you get if you distribute it?
-2 to the power of -3.
Right.
A to the power of -6. And then b to the power of -3.
What about the numbers on the right side?
5. A to the power of 2. And then 6. B to the power of 3.
That seems right. All right, -2 to the power -3. Is that -6, -8, +6, +8, or none of them? What is -2 to the power of -3 is the question. And these are your options. It's one of those numbers, or it's something else.
It's 1 over -8.
That's right, it's none of these. It's 1 over -8. And then A6 and B3, I'm just going to throw them in here for now. So you get 5A2, B3. B3s are gone. A2, you have to throw it down. So look at this, the final answer is 5 over -8, A4. And you are done, okay?
Mm-hmm.
This one looks weird, but how difficult could it possibly be? So on the inside brackets, they don't have any exponents, right? So you don't have to worry about distributing them. What you do is you straight up take your numbers. I like to group them up like this. I'm going to take my numbers. I'm going to take my m's. You can only do this if they're being multiplied or divided. If they're being plus and minus, then things are a little bit trickier. Then I'm going to take my n's. What is 18 times 32 over 4? 4 goes into 8 38 times, 8 times, and 4 goes into itself once. So we have 18 times 8, yeah?
It's 144.
Yeah, it's 144. What did the m's simplify to?
M to the power of -4.
What about the n's? What did the n's simplify to?
N to the power of 6.
Right. So the -4m, I'm gonna toss it down to make it positive. What's the square root of all this?
12, and then N to the power of 3, and then M to the power of 2.
And that's it. We are done. All these are just like that. This one looks weird, but it's not. It's just if you turn those exponents, the decimals, into a fraction, this becomes super simple. What's 0.5 as a fraction?
1/2.
1/2. What's 0.25 as a fraction?
1/4.
1/4. What do we get here if you FOIL this, if you distribute it?
Um, 6, M to the power of 2, and then N to the power of 3.
That's right. The other one is 3. What's the power of m?
It's 3.
It's also 3. N is 2. 6 times 3 is 18. M2 times M3 is M6. It's not M6, it's M5. You gotta add them up. And N3 times N2 is also N5, and that is the final answer. Okay? It's pretty straightforward, nothing tricky at all. It doesn't matter how difficult it looks. Let's look at this one. What's the square root of 64,812?
Eight, and then 8 to the power of 6.
Right. On the bottom, what's 1.5 times -6?
-9.
-9. We bring that up here, becomes a +9, right? Becomes a 15. Now what? We have 8a15 to the power of 2/3. What do we do here? Or is that the final answer? That is not the final answer. What you do here is you rewrite it as a radical. 8a15 to the power of 2/3. How do we write this as a radical?
The square root of
No,
the
again,
cube root of
cube
8a
root,
to the
yeah.
power of.
So cube root of 8a to the power of 15 squared, okay? You can do that first, or you can square them and take the key. I like doing it this way. What's the cube root of 8a15? Cube root of 8a15.
2a to the power of 5.
Yeah, 2a to the power of 5. Let's square this. What do we get?
a to the power of 10.
And that's it, easy peasy. This one also looks weird, but it's the same idea. As long as you know your exponent laws, it's just a few steps. Open the numerator there. X18 to the negative 1 over 6. What does that give?
X to the power of negative 3.
Yeah. What about on the bottom? And I'll tell you the fifth root of 243 is a 3. What's the fifth root of x10?
X squared.
X squared. What does the inside part of the bracket simplify to? So we have x3 on the top and 3x squared on the bottom. Do we move the x3 down or do we move the x2 up?
The X3 down.
Right, so what do you get? You'll get x5, yeah? Like that. Square root of this. You can't really do much with that. So that's going to be 1 over square root of 3 times the square root of x power 5, and that's going to be the final answer. And you're done with that. Let's do this one. So they've given us the volume of a sphere, 4 over 3 pi r cubed. And the question says, solve this equation for r. Alrighty, so this is our formula. V, that's not a square root, that's just a V. V is equals to 4 over 3 pi r cubed. How do we solve this for r? Which means isolate r. We only want r on one side of the equation and everything on the other side of the equation. We're trying to solve this equation for r. Basically involves moving, so whenever we're trying to solve for something, just move everything else to the other side. So here it would move 4 over 3 to the other side, the pi to the other side, and the cube to the other side as well. What do you think we do here? The final answer will be in this form. R is going to be by itself, and then we're going to have some expression on the other side.
You subtract 4 over 3.
No, because 4 over 3 is not being added, it's being multiplied. You don't subtract. What you do is you divide both sides by 4 over 3. Or you can look at it this way as well. I'm going to multiply both sides by 3. This goes away. How do I get rid of the 4? You divide both sides by 4, yeah? That goes away. And then we have pi r cubed. Now pi is just a constant. It's like having a 2 there. So what you do is you divide both sides by pi. So the pi drops down there. So now you have r cubed is equals to 3v over 4 pi. How do you get rid of that cubed?
You cube root.
Yeah, you cube root. So r is going to be the cube root of 3v over 4 pi, like that. And that's the answer in radical form. If you want the answer in exponential form, just move your index as an exponent. It's going to become 1 over 3, okay? It says, find the radius when the volume is that. For this one, you're simply going to replace v with that. So you get a cube root of, the volume is 3 times 256 pi over 3. On the bottom, we have 4 pi. 3 cancels out with 3. Pi cancels out with pi. This gives you cube root of 64. What's the cube root of 64?
It's 4.
It's 4. Therefore, the radius of this sphere that has that number as a volume is 4 meters, okay?
Mm-hmm.
Sphere is basically a circle. This is the area of a circle. Sphere is a circle in like 3 dimensions. It's not a cylinder, right? You know what I'm talking about. It's like a ball,
Mm-hmm.
like an earth. Earth is, for the most part, it's not perfect. Earth is more like an egg, actually. Earth is like, it's wider around its sides. It's not the perfect visualization, but the distance from here to here is higher than here to here. So Earth is an ellipse, it's called. It's not a perfect square, but you can imagine what a perfect square is, like a ball. All right, let's call it a day there for today.
Okay, thank you.
See ya.